Hello everybody, this is Asan Raju. As for the previous lectures, we have been learned with respect to different sensors and different types of sensors that are utilized in the mechatronic systems. And in that, we have identified that microprocessor and microcontroller. We have come up with these two technical words and how the programming will be dumped in the microprocessor, and that microprocessor will be read by the microcontroller, and depending upon the situations how quick actions will be taking place, we will be discussing in the today's class. And the topic relates to that criteria, that is microprocessor based controllers, microprocessor based. The topics of these microprocessor based controls over here: that introduction to the microprocessor, what is meant by microprocessor, how it will works, and microprocessor instructions, that is operational codes, of course in the sense here operational codes. What are the programming or set of instructions that are given in the form of a coding systems and mnemonics, and what are the advantages related to it, and some of the limitations and applications are being existing here. The main objectives of this microprocessor is nothing but what does it do and how does it works. So it understands the concepts of the RAM and ROM. So these are both different characterizations or technical terms. One, it is an temporary storing device, and ROM is an permanent storing device. How the memory is being accessed, how that is being accessed, and the data buses or the signals are being transferred from this microprocessor to the different actuators upon the guidance of microcontroller by utilizing the data buses or bus transformation unit, BIU, bus interface unit. And be able to understand the parallel and serial data interfaces work and the relevant calculations towards it were pertaining to transfer the data which is obtained in the analytical format and need to be converted to the digital format, and vice versa, that is obtaining in the digital format need to be visualized in the analog data. So for that the converters are required. Those are analog to digital converters and digital to analog converters, and the basic principles of this digital controlling software. And for commencement of overall these factors, we need the microprocessor, and that processor will be existing as per the directions given in the form of a set of instructions. And these and all are will be interconnected to the microcontroller, and controller plays a major important role here. And controller software will guide the overall components, how it need to be go get on in the work. So we'll be having a look at this. So recognize and description of these characterizations, that is microcontrollers and different components of the systemic devices. Microcontroller, single boards, computers, PLCs, and even our personal computers. And these and all are the components that are existing in our data, as we have been discussed, is personal computers, PLC systems, etc. So these are ushered in a whole new era for control systems electronics. And in the modern technology, that is electrical basis of technologies, this microprocessor plays a major important role indeed to transfer the signals instantaneously. So instantaneously at the in the format of signal strengthening, that is voltage form of signals. So these require The microprocessors required the temporary storage devices as well as the permanent storage devices and the BAU unit and even the cloud storing of data or even the personal storing of data. So these plays a major important role for securing the data, what the work has been commenced and what the work need to be done and whether it has been done in an exact format or not. So these and all of the statistics will be maintained in the memory devices, and if at all it has been necessary for an visualizer or operator, he will be storing in the permanent storage device or else will be neglected. And until the process completes, the temporary storage device will be coming into the force. So moving on to the architecture of this architecture of this microprocessor, it's made up of mainly four blocks. That is central processing unit, memory device, and the central processing unit is the basic phenomena which will be having the detailed arithmetic and logical calculations and control over the overall data that is being transferred from the input level to the output level by processing the commands executing as per the controller directions which are being processed by the microprocessor. So memory is nothing but the data that is being containing in it. And as we have already discussed that RAM and ROM, both temporary storage device and as well as the permanent storage devices, locations will be shared in need to store the data. These are the examples. And some more components. So input output ports will be existing for it. So input will be giving the feasible signals as an input to the system to be commenced, and output receives the signal after commencement of the overall process that you have been programmed to the system. So these connecting devices will carry these voltage signals or execution of these programs in the form of these voltage carriers plays a major important role. So for that particular purpose, we have already discussed this, but bus interface unit plays a major important role. So here, busing systems. So in these busing systems, there are mainly subdivided into three characterizations. First one it is address bus. So address bus here specifies that from which location to which location or where the signals need to be transferred. So for example, if the input has been given to the system and four different printers has been connected to it. So four different printers are manufactured or obtained from four different companies. One is LG or one is Panasonic, one is the Canon and one is the LaserJet something. So we are giving that particular address, the object or word copy that has displaying in the processor need to be get printed by LaserJet and corresponding address need to be specified. So that will be analyzed in an electrical format. So if that communication has been passed to that by the utilizing this address bar and directly the information that are constituting in the display screen as a processor that will be printed from that particular device. So printing device is nothing but the actuator. So that the task is being getting done by the printer and data bus. So here transferring of data between CPU and the device. So here actuator is one of the device. In that the electrical components such as a reader need to be existing, and depending upon the reader the printer rotation by the drum need to be taken place, and for that happening from the computer there should be an interface connectivity because the entire information that the displaying as per the processor schedule or editing modifications has been done need to be transferred from the CPU to the printing device. That is nothing but the data bus. Next one, controlling bus and timing and event control. such as the reading and writing operations, need to be controlled by utilizing this control bus. So here is the clear pictorial representation of block diagram of this microprocessor, and this is the microprocessor CPU ALU operations, arithmetic logical unit. This is, and the operations that are being progressed in this entire CPU is nothing but the ALU operations, arithmetic logical calculations. Arithmetic in the sense we all know aware of that additions, subtractions, multiplications, divisions, fractions, etc. And in the case of this logical characterizations and of or operations, some of the logical decisions, calculations that will be getting done and accessed with respect to the, it is interconnected with respect to the control unit and registers. So these registers are nothing but the storage devices, and temporary storage devices and the permanent storage devices are also existing over here. And these registers are having a capacity of storage characterizations, nothing but 4 kilobytes, 4 KB, 5 KB, 8 KB, or 8 bits of information, subclassified into the bits of information, and 8 bits is equal to 1 byte. So bytes of information, bits of information, and maximum these registers has been subclassified again into the flip-flops. So each and every flip-flop will be having the capacity of storing only the 1 bit of information, and maximum it is the 4 or 8 bits of information. So those flip-flop number of flip-flops will be considered as a register, and when we need to store the information in it, the bits number of bits will be considered over here, and the bytes will be considered, and the registers will be getting taken place. And upon the CPU and overall considerations, the corresponding address bar is being connected to the output, nothing but the actuators. Here to the actuator, nothing but the printing devices and memory device. Whether that program or modifications done in the CPU need to be stored or not, it plays a major important role. RAM and ROM, either it has to be permanently stored, or it has to be stored only on the temporary basis until that particular executing program has been commenced by the actuator. So after initiating or editing process and storage process, if at all further modifications are existing here, there will be an interconnectivity with respect to the controller RAM, and interconnectivity with respect to the input schedule, and interconnectivity with respect to this and controlling bus, interconnectivity with respect to the output cadre also even. And there will be some of the feedbacks when we have been considered the closed loop control systems. So closed loop control systems will give the feedback to the sectors, that is comparator, and comparator will compares the obtained data from the output and to the given input. And if there is an error furtherly, that error will be fed back to the controller, and this controller will again displays to the instructor. Those instructor will be getting done with an further modifications, and those modifications will be taking place, and again the input will be getting passed on to the characterizations or actuators, and furtherly modified data will be again commenced by this particular actuators. And let us discuss regarding the instructions and operational codes, and having the commands of moving the data, performing the mathematical operations, performance of the logical operations. So the instruction is a unique one code, and binary values associated to it. So binary values, nothing but as per our binary values 0 and 1, you know, the coding format or storing of the entire device in the digital format, we will be utilizing only 0 and 1. Those are nothing but the binary codes, and depending upon that, we will be giving or assigning the overall input instructions to the system to be operated. Here, an accumulator is an area for data moved into the state. and operations are performed in that particular data. So accumulator is also called as a temporary device. Accumulator is nothing but the temporary device that holds the data until that executing or processing has been commenced. Until the processor has been commenced. That's it. So machine codes or mnemonics PC. So machine code, the program that the CPU follows in binary code or hexacode system leads to the machine code and mnemonics and some of the abbreviations representing the opcodes. They're nothing but the operational codes. Nothing but left left indeed to move the actuator towards the leftward direction. Nominally, as per the theoretical representation, we will write that move towards the left, left. But here, in the case of digital coding system, there will be an left side symbol only lft, like that. So some of the codes towards the right are GT. In such a way, the mnemonics, nothing but the simple codes, parallel in the sense PARALLEL in the theoretical representation we will be having, but PARLEL, that is the code existing in our programming nature. Perpendicular, PARDLR, perpendicular. In such a way, the mnemonics are nothing but short terminal codes existing for writing a program or nothing but the assembly language used in the mnemonics. Right? Program counter. So using of the point that memory address of the instructor to be performed. Nothing but counter. How many number of times that a program has been executed. So how many number of times from the starting stage onwards that actuator has been came into the work existence. So that is the program easy for program counter. Memory address will be directly interacted with respect to the instructions to be performed. So fetch execute cycles. So perform to bring an instruction to a memory into memory and execute it. So this is the code fetching the data from the address region and next executing the entire task depending upon the instructions given as a program. So these are the instruction sets. So mnemonics will be detailedly displaying here. So microprocessor program counter. So 00 times it has been performed. 0, 1, 2, 3, and simultaneously 10 times it has been performed in such a way. The overall this program counter and the performance records will be stored in the registers as we have been seen in the previous block diagram. That registers, there is nothing but storage devices. Register nothing but the registers are nothing but the storage devices. So here address will be specified. Address is nothing but in which folder it has been stored, and nominal or nominally name will be specified to that particular registers. Nothing but casually we are utilizing the laptops and in which drive we are storing the data, D drive or E drive, F drive, and in that F drive we will be having subfolder. In that we will be having the again subfolder. So that subfolder names or address is nothing but the address from which folder we have been taken, from which drive, and in that drive the basic folder, and that basic folder to subfolder, and subfolder to assigning particular topic name, and in that topic name the concerned lecture number, and depending upon that the operational codes will be taking place, and this each and every operational codes we are also having in our CAD CAM subject also will be having this op codes, operational codes, in the form of indeed to perform the CNC programmings, computer numerical control technology programmings. So the mnemonics here specifies the operational code to be performed at that particular region, right? For example, in the milling operation need to be performed with respect to an one tool. The tool will be indicated and where it has to be performed in that particular corresponding object. So depending upon the manufacturing region, this processor will give the set of instruction to a particular through a particular port to the actuator, and simultaneously actuator will commence the processing actions on the live basis. Clear? This is an example for the instructions, and the architecture here it follows. This is the program counter, and it has been given to the operational codes, and these will execute these operational codes will check the with respect to the registers, nothing but the information stored in the set of instructions at that particular register, and in which register, just we have discussed now, in which register that particular values need to be taken, nothing but in which drive it has been stored, separate folder, in that subfolder, in that topic folder, etc. That operational code will give the instruction to pick up the concerned values which has been stored in a particular register, and those will be taking place and commencement will be getting done, and entire these actions will be monitored by a control bus, and this control bus is nothing but interconnectivity given to the controller, and reading of the data, and how much time it has been taken place, etc. So coming to the advantages, we have been already discussed, and will be shortly will be uh, moving on with respect to these advantages once again. High level of integration, number of subcomponents will be constituted as a single constitution, single strategy, and different tasks will be getting performed simultaneously at a single stage, and increasing in functionality and better design, using of these electronics and softwares, artificial intelligence, advanced technologies with respect to the existing technologies, multi-sensor and programming programs environment, high reliability and safety, getting the accurate values, etc. And we have already discussed the limitations, nothing but high initial cost or investment cost or installation cost of the machinery will be very much high in economical factor, and a very much complicated design. Only the skillful worker can understand the entire equipment setup and operational procedures also even, and repair and maintenance also very much cost, because only that skillful worker need to be get in operational for in operations for maintenance activities also even. Even replacement is very much difficult, because if any of these because it is an interlinked with respect to the microcontroller, if any one of the component has to be replaced, then there will be an some of the impact over other all the um, other all the components or different segments of our working scenarios also. It need to be get into the halting. So some of the applications that we have been already discussed was in domestic based and business based and industrial basis. These are the pictorial representations. Thank you.